Okay, we're going to do 3.6, the quadratic formula. This is the standard form of a quadratic equation, and we have solved by factoring, and we have solved by graphing, and we have solved by completing the square, and now we are going to solve by the quadratic formula. I'm not going to go through the process of solving for x on the video, but x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So you're going to substitute in the value of a, the value of b, the value of c into this formula. And that's how another way to find the roots. This one's probably used more than any of the other ways for whatever reason, but it's another way to get exact values. Also, you can see we would take the square root of a number, so this is called the discriminant. More on that in a minute, but we can tell a lot about the equation just by looking at what's underneath the square root. There's the equation again. And there is a song for it. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Practice that. You'll never forget it. Okay, the discriminant, like I mentioned, is probably one of the most important things that we're going to do. And I have found over the years that doing this separately, figuring out what's under the radical away from the rest of the problem and then substituting that number in there will eliminate a lot of potential errors that come up with this formula. It's going to tell you how many solutions there are, because if you think about it, if I'm taking the square root, I could either get a positive number, a negative number, or 0. And what we've learned about square roots to this point, those three things are going to have a different effect on the roots of our formula. If we are negative, we know that we do not cross the x-axis. There's no real solutions. We also say there are two imaginary solutions. And then if the discriminant is positive, we know that we have two roots. And you can't see this, so I'll draw it in. If the discriminant is 0, we have one solution. Notice, plus or minus the square root of a negative. That's why we get a positive and a negative for the imaginary. Plus or minus a real number when it's positive gives us two answers. And then if I have 0, now I'm adding and subtracting nothing. So my answer is actually negative b over 2a, which you might remember from the beginning of the chapter, talking about the axis of symmetry. Okay, so here we go. Get it. I always have to get it into standard form. Move the 35 over. X squared minus 2x minus 35 equals 0. I like to identify a as 1, b is negative 2, c is negative 35. This will alleviate problems. Okay, I like to solve for big D, the discriminant. Big D is b squared minus 4ac. I'm going to do that first. I'm going to put negative 2, square it, minus 4 times 1 times negative 35. This is going to be 2 plus, almost made my first mistake of the year, 4 plus 144. Remember, if you're squaring a negative, you must get a positive. That's a very common mistake. Negative 4 times 1 times negative 35 is positive. So this is 140. Geez, stay hot. And I get the discriminant is 144. So now I take the formula, negative b plus or minus the square root of the b squared minus 4ac all over 2a. Now I can plug in. X is equal to negative negative 2 plus or minus the square root of 144 all over 2 times 1, which gives me 2 plus or minus 12 all over 2. Now I can actually finish those problems. 2 plus 12 is 14 divided by 2 is 7. 2 minus 12 is negative 10 divided by 2. is negative 5. There's my two roots. Okay, if we had looked at this to begin with, is that factorable? Yep, it would have been quicker to factor it, but again, we're getting the process down for using the quadratic formula. Next, I will put the 5x squared minus 8x minus 4 equals 0. I identify A as 5, B as negative 8, and C as negative 4. I find that that will alleviate a lot of problems for you if you write those things down. Otherwise, we lose negative signs, and losing negative signs is a problem. And I get b squared minus 4ac is right there. And I get 64 plus 80. Oh my gosh, I got 144. Does that mean that our discriminant is always going to be 144? It does not. It means that the first two problems had the same discriminant. Negative b plus or minus the square root of 144 all over 2a, which will give me 8 plus or minus 12 over 10. Do them separately. 8 plus 12 is 20 divided by 10 is 2. 8 minus 12 is negative 4 divided by 10, negative 2/5. So far, we've had perfect square discriminants. You will not always have perfect square discriminants. It can be a problem. Next one. We're already in standard form. Identify A is 2, and B is negative 17, and C is 8. Plug it in. I like to solve for the discriminant first, which is negative 17 squared minus 4 times 2 times 8. Oh dear, negative 17 squared. I don't even know what that is. Grab your calculator. I got 289. 289 minus, what do we got there? 64. 289 minus 64 is 225. Hey, that's going to be nice. X is equal to negative b plus or minus the square root of 225 all over 2 times 2. Square root of 225 is 15. 17 plus or minus 15 divided by 4. 17 plus 15 is 32 divided by 4 is 8. 17 minus 15 is 2 divided by 4 is 1/2. Again, the first three problems we had, the discriminant was positive, and that meant we had two real roots. The discriminant was also a perfect square, which makes it a lot easier. We'll have a bunch of problems where we do not have a perfect square under the discriminant, which changes everything. Another example, 3x squared minus 5x minus 12 equals 0. Identify A as 3, B as negative 5, C as negative 12. First I do the discriminant, which is b squared minus 4ac. And let's see what we get. Don't forget, you're squaring a negative, it's a positive, and then I get plus 144, and I get 169. And we get another perfect square discriminant, and that's okay. X is equal to negative b plus or minus the square root of the discriminant, which is 169, all over 2a. And I get 5 plus or minus 13 over 6. Finish those two problems off to the side. 5 plus 13 is 18 divided by 6. 18 divided by 6 is 3. 5 minus 13 is negative 8 divided by 6 is negative 4/3. Two real roots. Again, we got a perfect square discriminant, and we'll see some examples coming up where that isn't the case. And here they come. Well, maybe this one works yet too. I forget. Okay, here we go. A is 1, B is negative 5, C is negative 12. You might be asking yourself, why do you write those down each time? It's such a waste of time. Well, that's 3.2 seconds that it takes me to do that will eliminate some mistakes. Same thing with b squared minus 4ac. And now I get 25 plus 48. 25 plus 48, ooh, get out your fingers and toes. I think it might be 73. Check my work. Okay, so I know that this is positive, so I already know how many solutions are there. 2 real roots. So that's where we can use the discriminant to tell the nature of the roots. because it's positive, I'm going to be doing plus or minus a square root of a positive. X is equal to negative b plus or minus the square root of 73 all over 2a. And now we get to a point where 5 plus or minus the square root of 73 over 2. I cannot simplify any further. 73 does not have any perfect square factors. Heck, I don't think 73 has any factors besides one in itself. So this is an acceptable answer. Some people, because the way we do imaginaries, complex numbers, we might want to split that up, and we can write it like this. And notice there are two real numbers there. They're irrational, though. Both of them are irrational because of the square root of 73. Oh, what are they? I found them. Okay, here we go again. 4n squared minus 4n plus 3 equals 0. I get some people who want to change those n's to x's, and that's just fine. A is 4, b is negative 4, c is 3. I do the discriminant to tell how many solutions they are and what are they, and I get b squared minus 4ac, and I get 16 minus 48, which is negative 32. Since the discriminant is negative, I know right now that I'm going to have two imaginary, no real roots. And actually, I can also say two imaginary roots. Okay, so we've got x is equal to negative b plus or minus the square root of negative 32, square root of 32, square root of negative 32. All over 2a. I would break the square root of negative 32 down into the square root of negative 1, the square root of 16, and the square root of 2. And remember, that's 4i root 2. So I'm going to have x equals 4 plus or minus 4i root 2 all over 8. So now I can put 4 over 8. 4 over 8 is actually 1 over 2. Plus or minus 4i root 2 over 8, I root 2 over 2. And there is your answer. Two imaginary roots, and we could tell that right up here. What are they? I found them. Okay, here we go. Boy, if we just got two real roots and we just got two imaginary roots, I can't imagine what this one's going to be. A is 16, B is negative 16, C is 4. Let's find the roots. The discriminant is B squared minus 4AC, which is 256 minus 256, which is 0. That's going to be one real root, and that's going to be also known as a double root. And here we go. X is equal to negative b plus or minus the square root of 0 all over 2a. Well, the square root of 0 is 0, so I have no plus or minus, and that's why we have one root. And I get 16 over 32. 16 over 32 equals 1/2. Answer's 1/2, one root. Okay, there we go. And that's it. Worksheet. Have a great day.